Hey guys, hopefully I have a lot of you watch this and through all this craziness that you still might learn some math. I know that we won't learn as much as I'd like to, um, but I would still encourage you to watch these videos that I'm going to post and then make sure that if you have questions that you can email me, you can message me in Canvas, you can call me at at the school's phone number. So please, as we're working through these problems, if you need help, just let me know. But we are going to start, and you guys probably already knew this because we started before the spring break on probability. And so most of you should know what probability is, right? It's the measure of how likely something will happen, right? So let's see if I can write neatly. I'm going to do my best. All right, so it's how likely an event is to happen. Now, the set of all outcomes. So think of the example that you guys had in your blue packets where we tossed a coin twice or we tossed two coins. What were all of what could happen, right? From oh, my hair looks lovely. From tossing the two coins. So with that example, hopefully you guys said, well, you could get tails and tails, heads, heads, then you could get heads, tails, and then you could get tails, heads. So you listed all of the possibilities. Well, that is also referred to as the sample space. So sometimes it's easy to list the sample space because then you can find the probability easier. I also did the same thing on the whiteboard when you roll two dice, right? There were 36 possibilities when you roll just two standard six-sided dice. Anyway, so moving on. So for equally likely outcomes, the theoretical probability, so like in theory, this should happen, this times out of this many times, is the possible, oh, you guys, my brain, it's weird not having any students here. I'm all lonely. Anyway, so sorry, is the ratio, right, or fraction of the number of favorable outcomes to the total number of outcomes possible. So, looking at this example right here that we have, if we have a jar, this is like one of your classic probability problems, right? You have a jar that has marbles, and there are 32 red marbles, and then there's 28 blue marbles, okay? And then what is the probability that a randomly selected, because everything with probability is assuming that it's random. Like you're not looking at the marble and specifically choosing something, it's just random. Anyway, so if we have 32 red and 28 blue, well, what's the total number that we have? That's going to be 60 is the total, right? So if we're wanting the probability that we're going to choose a red, well, that's how many reds there are in the jar, which is the 32 out of, well, how many total possibilities are there, which is the total possible marbles, which is 60. And then since we're smart and we just always like to simplify these fractions here, let's see, half of it would be 16 over 30, right? And if we do half again, 8 over 15. So 8 out of 15 times, in theory, I would get a red marble. So that's what probability is measuring. It's just how likely an event is to happen, given what you have, right? So looking at number 2, we have the word restoration. And if we randomly pick a number, like say we wrote each letter on a card and we put the cards in a hat and we randomly picked it, okay? What is the probability of selecting a vowel? So, oh dang, vowels. Let's see. Let's go back here, back. A, E, I, O, and U. Sometimes Y, but good thing we don't have to argue about that because there's no Y anyway, right? Okay, so then we're going to look at, well, how many vowels are in the word restoration? So we have 1, 2, 3, 4, 5. Looks like we have 5 vowels. And then out of the total possible letters in the word restoration, 8, 9, 10, 11. So it looks like there's 11 if I counted right. So 5 out of 11 times, in theory, we would select a vowel. Okay, so hopefully that's review just on basic probability. Because now we are going to jump to, well, what if we look at multiple events happening, right? So when multiple events happen, like if I like the probability of flipping a heads 2 times in a row, so flipping a heads and then another heads, then you need to look at, well, are those events, are they independent of each other or are they dependent? So, well, what the heck does that mean? So independent means when the outcome of one event does not affect the outcome of the next event happening. Okay? So when they are independent of each other, so think of like if you flip a coin and then you roll a die, like, or if I flip a coin time after time, that coin has no memory, right? So it doesn't matter what I got before, it's not going to impact the probability of what I get next. And that's the same thing with the coin and the die. No matter what I flip on the coin wouldn't affect what I roll on the die. So those are independent events. And so to find the probability of this, and this is a key word here, okay? So when you see this word and, that means you're looking at both events happening if there's just 2. So the probability of both things happening, not just one or the other, but both. So when you see this and they're independent, then all you need to do is just the probability of event A times the probability of event B. And you just multiply them. Now, if they're dependent events, so like the outcome of one event does affect the outcome of the other. The example I like to bring up is when you are playing a card game. No matter what card game you play, if you deal the cards out, so that's an example of dependent events, because what I deal to the first player will affect the probability of what I deal to the second player, right? So when that happens, when they're dependent events, then we're going to do the probability of A times the probability of B given A has occurred. Is it 2 C's? Oh my goodness, you guys. 2 C's and 2 R's? Forgive me. You know, I won the school spelling bee in 6th grade, but that was a long, long time ago. So if I misspell this, I'm sorry. Anyway, so probability of the first event times probability of the second event given that has occurred. So I'm going to go over an example with you. So I thought, classic example. So I have these jelly beans, Starburst jelly beans, and I will share them with you guys when I see you next, okay? I'll buy tons. So I got some out of my jar. I just did the first 10, so it's supposed to be random, but anyway, so these are the 10 that I got, the 10 colors, okay? So I'm just going to use, and out of these 10, look, I got gypped. 1 pink, no yellows, all these purples and greens. Okay, so I have 10 jelly beans. Okay, I have 3, you guys see that? Ooh, okay, so I have 3 purple. And then I have, I can't count and talk and write at the same time. I have 4 green jelly beans. I have 1 red and 1 pink. Like I said, I'm very unhappy about that. Okay, so I'm going to randomly select jelly bean, right? And we are going to find out, well, hey, let's do question 1. What is the probability that I'm going to get a green and then another green? So I'm going to randomly pick a green, pick another green. Now, the important question you should be thinking is, am I going to eat the first one or share it with somebody? Or am I just going to put it back? Because does that matter? Yes, it does matter, right? So if I randomly select a jelly bean, so right now, let's just look at the first jelly bean that I draw, right? Probability that it's green. If I close my eyes, pick out a jelly bean, right? Oh, that is green. You guys, that I didn't do that on purpose. That was, I truly closed my eyes. Okay, anyway, so the probability of green, you guys can tell I'm bored because I'm talking to myself. So probability of green is how many green there are out of the total. So it'd be 4 out of 10, right? Now, I am going to put this back. So I put it back in here. See, notice there's still 4 in there. So then what would be the probability the second one is also green? Well, what's the probability of the second one being green if I put it back in there? Are there still 10? Yes, there are still 10 and there are still 4 green. So then it would just be 4 out of 10 times 4 out of 10, right? Or if you wanted to make it easier, you could do 2/5 times 2/5. So it'd be 4 out of 25. So theoretically, 4 out of 25 times, if I draw one, replace it and draw another one, then it should be 4 out of 25 that I get a green and a green. So I'm going to make a little note here. This is with replacement, because by replacing it, then that's what made it independent, right? So let's do another one with replacement. Let me scroll down a little bit here. So let's do probability. I'm going to get a pink and a red. So if you look at, I have 1 pink and 1 red. This isn't likely, right? The green is likely because we have the most green. So that's why it's 4 out of 25. But pink and red, this is going to be a small chance that I get a pink first and then red. So probability of pink. I keep holding this up like, here, let me hold it up like it's going to help you. Oh my gosh. All right. Okay, so I have 1 pink, 1 out of 10. I'm replacing it, right? So I still have the 10 in there. And then I still have 1 red. So 1 out of 10 times 1 red out of 10 total. So then that will be 1 out of 100 times, theoretically. Okay, so this is, in theory, it should happen, but it might not happen every 100 times, right? So probability of pink and then a red will be 1 out of 100. Okay, now let's do, you know what? I'm going to eat these jelly beans or share them, you know, if I was a good person. But since I'm all by myself, I guess I'm going to eat them, okay? So, number 3. We're now going to figure out, well, now what's the probability? Oh, geez Louise. Of a green. Come on, pen. It doesn't want to write anymore. It just stopped. Guys. Sorry for the technical difficulties. It's really not. It's just not. Okay, so probability, I'm gonna pause this video for a second, see if I can fix this. All right, we're gonna try this again. We'll see how this works. Okay, so we're gonna look at the probability of me selecting a green, eating it, and then selecting another green. So probability of the first one is a green is still the 4 greens out of 10 total, right? But then now, see if my pen's gonna work. But then now, since I ate that green, then now there are only 9 in the bag. And 9 total, and how many greens? Since I ate the 1, means there are 3 left. So then, oh my goodness. I'm sorry, you guys. 3 out of 9. That's a 9. Okay, so, and if we wanted to simplify that, 2/5 times 1/3 would be what? 2. And 5 times 3 is 15. So 2 out of 15 times, oh my dear. 2 out of 15 times, theoretically, I would get a green, not replace it, and get a green the second time. Okay, so now what about a pink and then a red? So probability, oh, we're gonna do this one. Pretend like I randomly drew the pink and I ate it, okay? All right, probability of that was 1 out of 10. Oh, come on. Oh, you guys, I'm so sorry. 1 out of 10. Anyway, times, pretend that's a 10. Then, how many are left? Only 9. Well, you guys can't see. Only 9, and how many of them are red? 1 out of the 9. So then I'm going to go times 1 out of 9. I don't know why my stylus, maybe it needs new batteries. I don't know. So 1/10 times 1/9 is 1/90. It just won't do like the curves or circles. So 1 out of 90 times I would get a pink, not replace it, and then get a red. Okay, so hopefully this little tutorial, as weird as it was kind of helpful for you to determine probability of multiple events happening, and whether they're independent or dependent. Now, I'm going to bring up your assignment and go through one of the problems with you. Okay, so as I was pulling up your assignment, I noticed how, I'm just a blonde. Because when I was counting my jelly beans, I don't know if any of you noticed this. If you did, I'm so proud of you. But I was counting my jelly beans. Guess which color I forgot? The orange. So 3 plus 4 plus 1 plus 1 does not make 10. And I should have realized that, and I didn't. So anyway, so then I added the orange, and now that does make the total of the 10. So I apologize for that mistake. But at least I caught it before the end of this video, because that would have been embarrassing, right? Or even more embarrassing. Okay, so this is one of the questions that you'll have on your assignment. Your assignment is on Boom Learning. I put it on here so that you know if you are understanding it or not, and then I can see your results, so I know how you guys are doing. Anyway, so hopefully it will be good. You can use any online calculator, one on your phone, probably not that good, but there is one online. So one of the problems is, what is the probability of selecting an orange basketball, and then a green if each ball is not replaced. So if it's not replaced, then that's an example of the dependent events, right? Because if we're not replacing it, then what I pick first affects the probability of what happens after, second or third, or and so on. So let's just start with the first event. So selecting an orange basketball, right? So how many orange basketballs are there? Well, there are 1 out of the total basketballs is 5, right? And then we're not replacing it, so that one's out of the question, right? That one's taken out. Then a green. So then after that, we have these 4 left over. And so we're going to multiply because we want the probability of orange and a green. So that's multiplying these 2 events. And how many green are left? There are 2 out of 4 total, or you could just do 1/2. Because now I'll have to 1 times 2 is 2, 5 times 4 is 20. So 2/20, which simplifies to be 1/10. Why my pen's acting weird, but so 1 out of 10 times, theoretically, you'd select an orange, not replace it, and then select a green. So then on your assignment, you'll just put in that answer right here. If it wants it as a fraction, you put it as a fraction. If it wants it as a percent, you guys know how to make a fraction a percent because we do that every wonderful Wednesday. So hopefully this will help you. If you have any questions, please contact me, and good luck, and I'll talk to you soon.